Hello, period 3. We're going to go over our guided practice problems now for lesson 8.3. In this lesson, we're going to graph and write equations of circles. So we're moving out of parabolas for right now and moving into equations of circles. So we're going to start with our key concept. Here is the equation for a circle equation that is centered at the origin. We are going to center all of our circles at the origin because, oh, it's so convenient to do so. So any circle that is centered at the origin will take the form x squared plus y squared equals r squared, where r is the radius of the circle. And we're going to see why that is the case. So I've drawn a picture of a circle centered at the origin, and I've picked any random point on that circle and labeled it x comma y. So there's the ordered pair for any point on the circle. We can call it x comma y. And then I have drawn underneath that the radius, so you can see from the origin to a point on the circle, that is the radius, and I brought that radius right to my point that I've chosen as x comma y, and that means that I can draw a right triangle from the origin to the x coordinate position and then up to the y coordinate position. So I have a right triangle with legs x and y and a radius r. Then I can say, well, if I want to know how long that radius is, I can use the distance formula. And recall the distance formula is d is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So when you see the radical in my work to the right, you're going to realize that I am using the distance formula to derive this equation. For any point xy on the circle, using the distance formula, we get r is equal to the square root of x minus 0 quantity squared plus y minus 0 quantity squared. So I'm using 0, 0, and xy as my two ordered pairs and plugging them into the distance formula. When I simplify that, you'll notice it simplifies down to the circle equation x squared plus y squared equals r squared. Now we're just going to use that equation. You do not have to memorize the derivation, but I did want to show you where it came from so that it makes sense. Now we're going to move into guided practice 1, where we're actually going to graph an equation of a circle. The equation is x squared plus y squared equals 9. To graph that circle centered at the origin, we'll need to notice that that 9 actually represents r squared. To find out what the radius of that circle is, take the square root of both sides, and r will be 3. We are only interested in the positive value since a radius must assume a positive value. Then to draw the circle, what you're going to do is you're going to mark off 3 spaces to the right, 3 spaces up, 3 spaces to the left, and 3 spaces below the origin. You will label them with the correct ordered pairs as you see on my graph, and then you will do the best job you can in drawing a round circle through those points. Clearly you can see my artistry is lacking since my circle is not completely round, but it's good enough. So the same thing with yours. Do the best job that you can in connecting those 4 points, creating a circle. The next guided practice problem is to graph y squared equals negative x squared plus 49. And to graph that, first we need to get into standard form for a circle. So we're going to add x squared to both sides, and voila, we are in standard form for a circle. X squared plus y squared equals 49. And then we go through the same process as our guided practice 1 problem. We're going to identify r squared as 49. Then we'll take the square root of both sides, and we'll end up with the radius being equal to 7. So just like last time, we'll mark off 7 to the right, 7 up, 7 to the left, 7 below. We'll draw a smooth circle. I think my circle got a little better there, maybe, or not. We'll draw a circle through those 4 points and label all 4 of those points we identified on the x and y axis with their correct ordered pairs. Guided practice 3a, we're going to graph x squared minus 18 equals negative y squared. Again, first we will get into standard form of our circle equation by adding 18 to both sides, and then adding y squared to both sides. We can do that in 1 step if we want. I chose to do it in 2. And our equation for our circle is x squared plus y squared equals 18. Just like before, that number 18 does represent r squared, so r squared is equal to 18. And the square root of 18 is shown to be r. The issue here is that we need to figure out the approximate value for the square root of 18, and I'm going to use my calculator to find that. Remember, depending on the calculator that you use, you will either need to push the square root button first and then the number you want to find the square root for, or you might have to do it in the reverse order. So play around with it on your calculator to know if you need to push the square root sign before or after plugging in the number 18. You'll find that it is approximately 3.5. We're going to round off to the nearest tenth when we are finding our square roots here, so that we know where to place the points on our coordinate plane. Also notice that I did write that radius in simplest radical form, and I box that up because technically that is my answer, simplest radical form, but that really doesn't help me when I'm trying to figure out where to place the points on the circle. So that's why I then went ahead and figured out the square root of 18 as approximately 3.5. Just a review on simplest radical form. We broke 18 down into 9 times 2 because 9 is a perfect square. That perfect square comes out as 3, and the square root of 2 does stay inside its prime and can't be broken down any further. So you see my graph at the right. I have placed my points 3.5 to the right, 3.5 up, 3.5 to the left, 3.5 down, labeled them with their correct ordered pairs, and drawn a beautiful circle through all 4 of those points, or as beautiful as I can make it. Okay, guided practice 3b. We're going to graph 3x squared plus 3y squared equals 15. We're going to identify the length of the radius as well. So the issue on this one is that we're not in standard form yet, because when we're in standard form for our circle centered at the origin, we will only see x squared plus y squared. But we see some coefficients on the x squareds and y squareds. If we divide by those coefficients, we'll get into standard form in one step. So I divided all of my terms in my equation by 3, and so my standard form equation for the circle is x squared plus y squared equals 5. Therefore, my radius squared is 5, and my radius then will be the square root of 5, which is approximately 2.2. So again, I've drawn my circle centered at the origin through all of the points that are 2.2 spaces away from that origin, and labeled my 4 ordered pairs that determines my circle. I think I got a little bit worse at drawing my circle this time, but you guys will probably be much better at drawing nice round circles through your points. Finally, guided practice 4. That's where we're going to end with our guided practice today. You're going to write the standard form of the equation of the circle that passes through 5, negative 1, and is centered at the origin. I drew a picture of what they told me so I can see clearly what it looks like and then what I need to do to write the equation. So I drew a circle through the point 5, negative 1. That will be my first step. Once I have that circle drawn through whatever point they give us, then I'm going to draw a radius segment from the origin to that point and label it R. And then I will go ahead and draw in the x coordinate and the y coordinate as you see on my graph. I go 5 to the right, 1 down, and I will be at my point. There's my right triangle that I'm going to use to figure out my equation for the circle. I know that the equation for my circle centered at the origin will take the form x squared plus y squared equals r squared. Since my x coordinate is 5 and my y coordinate is negative 1, I'm going to go ahead and square both of those. And notice on the 1 squared, I didn't square negative 1 because I know I'm going to end up with a positive value anyways. You can simply take the absolute value of whatever coordinates you're given and square those, since they will end up being positive always. So 5 squared plus 1 squared is r squared. My r squared then would have to be equal to 26, which means I can immediately write my equation. X squared plus y squared is equal to 26, replacing my r squared with 26. The guided practice problems we just went over are like the problems you'll be working on your own, so please refer back to these as necessary. And this homework will be due tomorrow, and we will submit it through Google Classroom as we learned how to do yesterday. Okay, I'll see you again soon.